All right, so this is the second video and final video for section 7.2. We're talking about confidence intervals in general, not just for data that comes from a normal distribution. So why don't you pause, copy, play. All right, so this example is, as stated, super cool. So in World War II, the Allies, United States, United Kingdom, China, Russia, France, were trying to figure out sort of Germany's tank production. How many tanks a month were they producing? Okay. And so some statisticians attempted to do so via confidence intervals. And what they looked at was the serial numbers of captured or destroyed German tanks. So that was the data they received. Okay. So let's set up what they did with some canned numbers, and then I'll tell you, well, the book will tell you how well they did. So theta is going to be the number of tanks produced, and we don't know that, but we want a confidence interval for it, right? Then we've got the serial numbers. So x1 up to xn are going to be the serial numbers, and we will assume that these are uniformly distributed between 0 and theta. So, you know, if they produce 1,000 tanks a month, the serial numbers would be from 1 to 1,000, and we would assume the tanks that we destroyed or captured were randomly distributed amongst 1 to 1,000. Okay. All right. So in chapter 4, for a uniform distribution, the maximum likelihood estimator of theta was simply x max. And also in chapter 4, we figured out how to find the PDF of x max and x min for any distribution, but in particular, and including a uniform distribution. Okay. So in chapter 4, the expected value of x max was n over n plus 1 times theta. So that's clearly a biased estimator. But since it's simply a multiple of theta, I can take the reciprocal times x max, and that would be an unbiased estimator. Okay. All right. Well, the PDF for x max from chapter 4 again is given by this. So remember, we had a formula involving lowercase f and capital F and powers of n to get the PDF of x max or of x min. I just applied that using the PDF of a uniform distribution. In this case, it'd be for u 0 theta, it'd be 1 over theta. Okay. So there's some details I'm skipping over here. Right? All right, well, it's quite simple to show that if x1 through xn are uniformly distributed between 0 and theta, then x1 over theta, x2 over theta, xn over theta are uniformly distributed between 0 and 1. So instead of looking at the actual data, I'll look at this data. And I'll look at y to be x max divided by theta. And using those chapter 4 techniques, I can figure out the PDF and the CDF of y being x max over theta. Okay. All right. And y clearly goes from 0 to 1 because it's uniformly distributed from 0 to 1. Okay. All right. Well, the x max over theta is uniformly distributed from 0 to 1. All right. So I've got a lot of setup there. We're going to use it on the next panel. So y, that x max divided by theta, is going to be my pivot. X max divided by theta depends on the data to get the x max and the unknown parameter theta, since I'm dividing by theta. But its distribution didn't. If you look at your PDF and your CDF for y, you never use theta. So that's our pivot. Okay. So pause, copy, play. All right, so if I want a 95% confidence interval for theta, I need some quantiles. So for the 0.025 quantile, I'm going to use the CDF of y that was on the previous panel and set the y value equal to quantile 1. So the CDF of y was y to the 400. So there's q1 to the 400 equals 0.025. Solve for q1. Do the same thing for 0.975 for the second quantile. And now the data we've been given is, we've been given that 400 tanks were captured or destroyed, and the highest serial number we found was 3476. Okay. All right. So the quantile information tells me that 95% of the probability is that y lands between 0.9908 and 0.9999, right? Now, y is x max divided by theta, our pivot variable. I'd like to solve for theta. So first I'm going to flip the fraction, but when I do, I need to flip these and reverse them, okay? So that's what happens over here. 1 over 0.9999 is definitely smaller than 1 over 0.9908. So we have to flip the sides. Okay, I can then multiply everything by x max. I could replace x max with 3476, and I get theta is between 3476.2 and 3508.2. And that is the 95% confidence interval of theta. So it's telling us total tanks produced on this confidence interval is between 3477 and 3509. Okay? And our expected value is going to be that M, okay, we've done this. The expected value of theta was going to be n plus 1 over m times x max. That would be our estimator of it. So that'd be 401 over 400 times 3476, whatever that is. Okay. Now, going back to World War II, what the book says is a lot of folks thought that Germany, the Nazi German war machine, was producing about 1,200 tanks per month. The Allied statisticians did work very similar to this and decided that they thought it was going to be about 256 tanks a month. So the statisticians thought Germany was producing way less tanks than other people thought. After the war, according to German war records, they were producing about 255 tanks a month. So the statisticians were within 1 tank a month of being correct, and other estimates were off by almost 1,000, by almost a factor of 5, factor of 4, I guess. So, yay, statisticians. Boo, Nazis.